If you look across India, you'll see everything from tiny toy workshops to massive steel plants. How do we actually organize this chaos? We sort every single factory using just 4 invisible pillars. The first pillar is what they eat, their raw materials. Are they chewing up cotton from farms or iron ore from mines? The second is their role. Do they make basic materials for other factories or consumer goods straight for your shelf? The third pillar is money. If they invest under 1 crore rupees, they're small scale. Any more, and they're large. Finally, who owns it? Is it the government, a private family, a joint venture, or a cooperative like Amul where the farmers own the factory? If you want to classify a factory, first look at what it eats. If it runs on things we grow, like cotton for textiles, it's an agro-based industry. But if it chews up rocks and ores from the earth, like iron and steel, it's mineral-based. But here is the strange part. Some factories don't make things for us. Basic or key industries, like steel mills, just make ingredients for other factories. Meanwhile, consumer industries make the final goods you and I actually buy, like sugar. Let's talk money. In India, the magic number for classifying a factory's size is exactly 1 crore rupees. If your total investment is under 1 crore, you are a small-scale industry, like a local toy manufacturer. But the moment you cross that 1 crore line, you instantly become large-scale, like the massive Tisco steel plants. But who actually owns the factory? That dictates our next major classification. If the government runs it, it's a public sector industry, like Bell or Sale. But if it's owned by a private individual or a family, it's private, like Bajaj Auto. Now, what if they team up? When the state and private individuals run a company together, we call it a joint sector, like Oil India Limited. And the most unique? Cooperatives. This is when the actual producers of the raw materials own the factory together, like the dairy farmers who built Amul. We're chasing a massive 25% GDP target, but these giant engines of growth have a dark side. Look at a typical large-scale plant. Up top, smokestacks choke the sky with sulfur dioxide and carbon monoxide. And all around it, the deafening roar of heavy machinery creates invisible but damaging noise pollution. But the damage doesn't stop at the factory gates. Below ground, untreated chemical effluents bleed into our rivers, poisoning the water supply. And even clean water becomes a threat when it's used for cooling and dumped back in boiling hot. This thermal pollution suffocates aquatic life instantly. It sounds bleak, but we actually know how to fix this. We can trap gases with electrostatic precipitators before they escape, treat wastewater in 3 distinct stages, and use cooling towers to bring temperatures down. The goal isn't to stop manufacturing, it's to clean up its footprint. So, how do we clean up the act? To stop sulfur dioxide and carbon monoxide from choking our cities, factories install electrostatic precipitators inside their smokestacks. It acts like a giant electric magnet, zapping and trapping toxic dust before it ever reaches the sky. For the toxic sludge dumped into rivers, the law demands a strict 3-stage treatment. First, mechanical screens filter out the big solid chunks. Next, biological bacteria are unleashed to eat up the organic waste. Finally, chemical treatments purify the water until it's safe to release or recycle. Ultimately, we can't just turn off the machines. Manufacturing drives 17% of India's economy, and the target is 25%. But by mandating these controls, along with cooling towers and silencers, we can build our industrial future without destroying our home.